Well, the sad thing is that last time, which I think was over a year ago, not much has changed since the last JDK IO 8 presentation on Java EE 8. So I will give an update as for what are the new features that are coming along on Java EE 8, what is going along with the what's going along with the progress, and also discuss the Java EE Guardians and the effort to get Java EE 8 moving again, and how you can get involved and actually participate in the process. So for the agenda for this presentation today, I'm going to go over an overview of the specifications that are a part of Java EE 8 and provide their current status or lack thereof. Give examples of some of the proposed enhancements and new features that are coming along, and then finally go over the status of Java EE 8 and what you can do to help, how you can get involved, and the organization that's actually sprung up around this. So Java EE 8 is incredibly important to the health of the Java ecosystems. As you remember, Java started out initially on the desktop with an applet and then somehow transmuted into a server-side technology which is used just about everywhere in the world. There's millions of Java developers, and most of them, with the exception of the Android developers, are most likely writing Java backend code that resides on the server. So EE is incredibly important to the health of the ecosystem. So this is an adoption survey that we conducted, and as you can see, we have pretty hefty adoption of Java EE 7 and some of the other. We still have quite a bit of Java EE 6 and Java EE 5 out there, as well as the Spring Camp, but Java EE is critical to the platform and to the continued structure of it. And Java EE 8, what many developers don't realize is that many developers don't necessarily think of themselves as Java EE developers. You might be writing JAX-RS web services or doing stuff with SOAP. That's all under the umbrella of Java EE, and that's why it's so important to the platform. So if you're writing JSP pages, that's Java EE. If you're working on JMS, that's Java EE. So that's why Java EE is so important to the platform. So few open standards have such a breadth of different implementations that are out there. I mean, if you look at, this is one of the few, this is a humongous ecosystem. We've got multiple Java EE servers to pick from, where you can take your application, write it for Oracle WebLogic, and also deploy it on Glassfish or Pyra, JBoss. You have the option of moving between different technologies, moving between different implementations, trying out and mixing and matching different implementations, which is very unique to the system. If you look over at the .NET world, you really don't have that. So everywhere else it's uniform stacks. So for the last 15 plus years, we've had a robust ecosystem that has continued to grow and thrive, which is really amazing. One of the important community efforts, and it's also community driven, and one of the important new community efforts is the Microservices and Java EE. You can check out the link there at the bottom. So it's this effort to basically create a microservices a standard specification for doing it, and it's involving many of the main vendors that are out there. Including pulling together Tomitribe, Swarm, Pyra is also involved. So check that out, and hopefully that will be a part of the Java EE thing. Now, looking back over the history, so before I get to where we're going in the future, it's helpful to look back at the beginning. It's hard to believe that Java EE has been around so long that somebody that's in kindergarten right now might actually be coding Java EE. So it's been around for what, 15 plus years. So this is a really long-lasting technology. If you look back at if you were writing code back in 1985, you probably weren't still using the same technologies in 1995. So there's been, it's been a long run, long stable platform over that many years. The fact that you can have an application written back in 2002 that still runs today is a testament to its longevity and support. Just looking at the history, if we go back all the way back to Java EE 1.1, you can see that we made quite a bit of progress over the years and it continues to grow. So prior to Java EE 5, basically we established a platform. At the beginning it was initially complex. Initially we thought it was great, but then decided it was too complex. And then we had other peripheral projects such as Hibernate and Spring that popped up. And what Java EE did, because Java EE is a standard, we took them, we pulled those, absorbed those back into the platform. So we took the lessons from Hibernate, standardized it, and then you could write standard persistence code for JPA using a Hibernate implementation and Eclipse Link implementation on different app containers. So that's one of the things with Java EE and going through this presentation. Java EE is a standard, so you look at what the industry has done, and then you standardize what you consider the best implementation or best practices for it afterwards. It's not, it's not like Apple where you come out, surprise everybody with a brand new feature and then find out whether they actually like it or want to use it. So that's what sets Java EE apart. So as a result, Java EE remains one of the easiest platforms to use today. Java EE 5 and Java EE 6 marked kind of a turning point. It became much easier to use. The industry, reception of Java EE 6 has been great with a growing adoption of Java EE. Java EE 6 also introduced the lightweight web profile, with the movement to make the platform as light as possible. Also introduced CDI, which is becoming more and more of a central part of Java EE. Java EE 7 was largely an opportunity to build upon the success of Java EE 6 and to make sure that enterprise developers are ready for emerging challenges. So in Java EE 6 we introduced standardized JSON support into the platform, standardized support for WebSockets, enhancements were made. We added in batching was added to the platform, which I'll be discussing later today. So there are a bunch of enhancements that were made to Java EE 7. Java EE 7 also heavily involved the community. So there's a lot of community feedback that participated in that via the JCP and the JSRs. And anybody in here can actually get involved with the standards. So the standards that I'm talking about today, everyone here, you can actually get involved, you can vote, you can make comments, and you can recommend changes to the standards. So, and then Java EE 8 is going to build upon the advances in Java EE 7. So, right after they completed Java EE 7, they conducted a survey over the course of 3 months and got over 4,500 responses for features that they'd like, developers, this is you, saying what you'd like changed in the platform. So Oracle and the committees took this to heart and driving, what was going to be the changes to the Java EE platform. So as you can see, there's a heavy emphasis upon simplifying security, right? Adding in caching into the platform, security interceptors, MVC, caching finally. Pruning, surprisingly, pruning was pretty small. Support for cloud, server-side events. Embedded, so they took all of these into account for drawing up the roadmap for Java EE 8, and this was driven by the community. So, as I mentioned, they took it into heart. So, for Java EE 8, we have continued enhancements for the web security alignment. So one of the big things that's coming along is HTTP2 support, which is a major revision for HTTP2, which has been 15 years in coming. JSON bindings. So in Java EE 7, it was great. We could finally work with JSON easily without writing our own string without parsing it manually or using a third-party library. But, it didn't quite have the nice JAX-RS stuff with XML where you could take and read in JSON and turn it into a Java object without having to write code to do it. So that's what JSON bindings is doing. JSON-P for parsing, there's more enhancements to the parsing support. Support for MVC. Cloud enhancements, so security, adding in RESTful management, API, etc. Those are a little bit in doubt. The CDI programming model, so CDI is fast becoming the center for dependency injection within the platform, so it's trying to uniform that across EJB and bring everything in underneath the CDI roof. And then smaller but more important changes, caching, which it had been hoped that that would make it for Java EE 7, but that didn't exactly happen. The spec is actually done, but for Java EE 8, hopefully it will be integrated into the platform. And then alignment with Java SE 8, taking some of the changes from 8 and probably getting that back into the platform. There's a good presentation by David Blevins. I think it was a Java 1 or Devox, where he talked about pulling, Java SE 8 changes for Java EE, how to code things differently, and opportunities for taking the enhancements in 8 and bringing it into the Java EE platform. And also pruning, so hopefully going forward from the baseline from the platform, Corba will be removed, so that will not necessarily be required anymore. which will simplify it and make it easier for vendors to support the platform. So the specifications that are looking like they're going to make it into Java EE8, JMS 2.1, JAX-RS 2.1, and I'll talk about each one of these in depth. So you can see the different specifications. The management one looks like it's probably not going to make it in. Now, everything was moving along fine until about after Java 1 last year, when many of the spec leads and the discussion list just kind of seized up and progress stopped being made. So ones like the JMS, the spec lead was actually very public, saying that Oracle had told him that he couldn't work on it anymore. So things have kind of slowed down in the past year, and recently Oracle's at least committed, although we haven't seen much progress on the discussion lists yet for it. So things have slowed down substantially. So it's important that the community get involved and help push it along, and make Oracle and keep the specs alive. So with that, I'm going to dive into the updated specifications, and then after the updated specifications, I'll talk about some of the new features some of the new specs that are brand new to the platform that are coming through. So the first one, and one of the very important ones, is the Servlet 4.0 specification. This one has actually been moving along at a snail's pace, sadly. There's been no activity since Java 1 of 2015, so the mailing list has basically kind of died. The early draft review has been published, and it is available for download. However, I don't believe voting has taken place yet on it. You can check out, there's some good presentations on the Servlet 4.0 spec and how to use it. If you check out Ed Burns' presentations, I think from Java 1 last year on it, I had to find out more information on it. So Servlet 4, is one of the most, as I mentioned, is one of the most important changes. It adds HTTP 2 support. So HTTP 2 is basically modernizing the underlying internet protocol to boost web performance. So if you look at how, when HTTP was first introduced in 1.1, 1.0, and 1.1, how we're using it today is very different from how it was used in the past. In the past, most pages were like Wikipedia pages, right? You were downloading content links, you navigate between the links. Now we have, single-page applications, that you can take those applications and turn it into a mobile phone application. So things have changed quite a bit. And with that, when the server reaches out and requests a page, there's 30 or 40 resources that have to get downloaded. So right now that's done, multiplexing over a single connection. There's all kinds of problems that can occur with that. So for instance, I think in the US we had that healthcare.gov rollout where the initial servers crashed the first couple of weeks that they were trying to roll it out, and they hadn't minified or condensed any of their JavaScript files. The landing page was, but the rest of the pages had 40 files that you had to download. So with Servlet 4.0 is trying to condense that so it's not as much effort in terms of deploying your application. You don't have to consolidate everything. So as I mentioned, it's a major update. So the problem with HTTP 1.1 is head-of-line blocking. So basically what we're doing with the Servlet 4.0 and the HTTP 2 implementation is when the server requests a page, the server responds and says, okay, here's the page, but also it pushes down to the client all the resources that it's going to need for that page, because the server knows what the client's going to need to request, right? So right now, when the browser requests a page, it then goes to the page and says, okay, I have to download this style sheet, this JavaScript file. The server already knows that and can push them down in advance to the client, thereby reducing the amount of time and also the number of socket connections and other things that could have to happen. So as a part of that, we've got HTTP pipelining, file concatenation. So this is trying to get around some of the problems in the past where people would take and ship down a graphic that was composed of sprites and then split that out into graphics for the site. So it was this. So this is going to result in significant performance. Now down at the lower level, so Servlet 4.0, you're not going to necessarily have to write your application differently in order to take it. This is going to be done underneath the hood. So if you're using JSF, it'll be taken care of, or should be taken care of for you. So we're going to have request response multiplexing. Down at the lower levels, there's basically binary framing that's going on. Socket optimizations, and then also it'll upgrade the connection from HTTP 1.1. So under the hood, there will be prioritizations for streams. So you'll be able to say there'll be this new priority class. There'll be enhancements to the HTTP servlet request and HTTP servlet response. There will also be support for server push. Server push, if you're familiar with the HTML5 stuff, you had WebSockets and you also had server-side events, so this is including support for the server-side events. So it's not a replacement for WebSockets by any degree, but it's adding. There's also plans to expand this API down to the client side, so it would replace legacy HTTP URL connection class in Java SE9. So it's trying to synchronize the plans with the changes to Java SE9. So anyways, this is major things. For many of us, I don't typically follow the servlet spec because usually I'm working at a higher level of dealing with RESTful services, but this is critical to the platform because we need HTTP2 support on the platform for going forward. So the next specification is JMS I'm going to talk about is JMS 2.1. It is still in the early stages. There are no builds available for testing as yet. Progress was actually moving along very nicely last year. So Nigel, who is the spec lead, was holding practically weekly calls, which were kind of interesting to call. Anybody could call into these calls and argue, with the specification. There were meeting notes were going out, and there's some very interesting in-depth calls as for what was going to change with JMS 2.1. They were trying to pull that together. As of last December, it completely ground to a halt. Nigel at Oracle, who was actually very nice. He posted a message that he wasn't going to be able to host the meetings. I then asked, well, I'll host them for you, and he said, well, I can't let you do that. So it was Oracle I'm guessing that probably got him into trouble when he replied to that one. So it's still in the early draft review. So you can check out the planning documents. There's some very good documentation up there. So what was planned for JMS 2.1? It's incremental change because JMS 2.0 was a major change. So we've gone better part of a decade without any real changes to JMS. 2.0 came along and made some enhancements to that, and so 2.1 is making some incremental changes to JMS and also improving some things from the 2.0, which they ran out of time on. So for instance, the focus is on modernizing the API, simplifying asynchronous message listeners. Declarative messages will be the primary focus, so you would be able to add annotations, basically I think like on message, to mark something as receiving a message. Improving JMS provider portability, and perhaps adding some of the advanced features that you get if you're using like ActiveMQ, some of the advanced features in the queuing systems, like redelivery delays. If this message fails, you want to roll it back and you want to have it redelivered 5 minutes from now to standardize that finally, so it's not vendor implementation specific. Redelivery limits, dead message queues, etc. So that was the goal with Hope, was to finally get around to cleaning up a few of those things. And then also adding support for handling of batch messages. So this is an example of one of the early prototypes. This is not exact. This may not be how it actually ends up, but being able to specify that you want to be able to, on your on message, you want to receive a block of messages. As opposed to receiving one message at a time, you could receive a batch of messages, which you could then process. Okay. And then declarative JMS listeners. So this is an example. So we have, max concurrency of 10. The JMS listener. So, with the CDI annotation for transactional, so we're specifying that we want to, select for, messages that have mobile in them. A batch side, we want 10 messages at a time delivered. It'll retry if for any reason we fail to process a message, throw an exception or gets rolled back. Retry for 5 times with a retry delay of 7,000. So these are some of the changes that are hopefully coming in JMS 2.1, which will be much needed for the platform. JAX-RS 2.1, JAX-RS, the RESTful web services, of course, is critical for the platform when we look at what's going on right now with HTML5 and how people are writing the web front ends, right? So so in many cases you're calling RESTful services on the back end. So unfortunately, JAX-RS 2.1 is in dire need of assistance at this time. There are no builds yet available for testing or to play around with. We're still at the early renewal ballot stages. So there's not much been going on. Oracle is heavily involved in this one, and there's been little or no activity with it. However, that being said, the targets for JAX-RS 2.1 were originally, better hypermedia support, reactive API, adding support for security API that would allow users to use their popular reactive programming model, support for server-side events, improved CDI integration, so you'd actually be able to use CDI more with JAX-RS, support for non-blocking I/O in providers, so that you could actually write providers or filters that didn't use blocking I/O. So some of the other additional features, JAX-B was going to be made conditional for runtimes. So this is actually a major one, so it might actually get removed. Providing integration with the upcoming JSON-B, the JSON binding protocol. So right now, if you're using like Pyra, it handles it for you, where you can send up JSON and it will turn it into Java objects. That is actually not standard. So between JSON-B and JAX-RS 2.1, the hope was to actually standardize that. And then support for CDI in Java SE, so that you could actually use JAX-RS 2.1 in a Java SE environment and have CDI support with it, be able to do dependency injection. So that's it for JAX-RS 2.1. For JSF 2.3, progress has been moving along fairly well with JSF 2.3. It is primarily the reason why progress has been moving along so well is that it's due to the expert group, and they have actual commit rights, and so they've actually been releasing stuff. So it's actually not completely controlled by Oracle. So the specification leads, Ed Burns and Manfred Ream, have been doing an excellent job with it up until the stall on the Java EE stuff. So with this one, there's actually documentation. There's stuff out there that you can go look at right now and play with. So what can we see out of what are the expectations with JSF 2.3? Enhanced CDI integration, lifecycle enhancements, so we'll get post-render view events, enhancements to the expression language, enhancements for the configuration, and then more AJAX enhancements to make it easier to work with JavaScript components. And then with the configuration enhancements, the CDI beans will actually be the preferred over the managed beans that came with JSF. So in terms of CDI integration, as you can see in this case, you'll be able to actually inject faces context. There's like codes floating around there that I think I paste into every project that I use to produce that CDI context, so I can actually inject it. So you won't have to do that stuff. It'll actually be built in. This is getting the application map injected in, so there'll be tighter integration with CDI, so it's not like two worlds where, it's like, okay, when can I use some of my CDI stuff? Because sometimes it's a little confusing when you can get stuff injected or not. Support for injection. It will now be possible to inject it will now be possible to inject these artifacts into JSF, so we'll be able to inject converters, validators, behavior. They'll also be upgraded to CDI qualifiers. Okay. So, quick overview of JSF 2.3. For CDI 2.0, this is another specification which has been moving along fairly well. So there's test reference implementations available. It's being heavily driven by Red Hat, of course. So if you go up to the Weld blog, you can see what's coming along with CDI. So if you follow that link, you can get the latest information. You can also follow the expert group to see what's going on. But CDI 2.0 is another major one. This is the first major set of changes to CDI since it was introduced to the platform. And CDI is becoming more and more the central focus, of the platform, trying to unify things. So after Java EE 6, there have been 2 point releases as CDI 1.1 and CDI 1.2. So fairly ambitious goals for this one. The goal in CDI 2 is to support a feature subset in the Java SE environments, including a standard Bootstrap API to make it easy to get CDI up and running in a thing. It would be nice to be able to use CDI for those of us that are still writing like JavaFX desktop applications, to be able to actually have better CDI integration on the desktop. So that's one of the things that will be tackled. Although CDI is focused heavily on annotation support, finally adding in full XML configuration support, so it's easier to integrate with enterprise integration frameworks or ESBs. Integrating the EJB annotations, startup, asynchronous, schedule, all for managed beans into CDI. Simplifying the plugin support via the SBI. So plugins have been incredibly important to CDI. So if you're using CDI, hopefully you're using like the third-party like plugins like Delta Spike with it, which add a bunch of things with it. So CDI 2.0 is a fairly major enhancement, also asynchronous events. So this code example, it demonstrates how CDI could be made asynchronous. So in this case, when we call event fire, it actually invokes it asynchronously and returns immediately. So this is one of the proposed API changes. So CDI, or two of the potential ways of doing it. So one of these two will actually become a reality. This code sample shows how EJB schedule annotation can be made available to all managed beans via CDI. So you wouldn't have to do this using EJBs, because right now the scheduling capability is only over in the EJB side of things. So this would expose it out. Standardized as a simple CDI intercept, this annotation can be used with CDI stereotypes as well. So this would be a very nice enhancement. So this is kind of unifying the platform more, so the things that are available in EE are available with CDI. Because a lot of times if you say I'm going to use EJB with a project, you'll have somebody that freaks out, right? So CDI is kind of the dark horse that's standardizing and making it more acceptable in some cases to use. Because if I sit back at the office, I've got some people that it's like you can't mention the word EJB to, right? Because they think back to the 1.2 days and they don't realize that things have changed in between the things. But I still get quite a bit of that. So anyway, so we'll pull some of these things over into CDI so they'll be able to use some of the features there. The next one, JSON-P support. So this spec has seen some great activity early on, but of course it screeched to a halt after Java 1 2015 as well. So after that, progress kind of stopped. It's kind of interesting because if you look at the specs, you'll see last year there's a lot of activity before Java 1, and then afterwards everyone, I guess, went on, everything just stopped. So there's some great presentations online from last year's Java 1 that you can check out. The sources, you can check out the links there for more information on it. So this is basically updating the lower level JSON parsing API. So like many other standards today, JSON standardizing is moving forward steadily. So with 1.1, we're adding in support for pointer and patching. So basically this is editing operations on JSON objects and array. Helper classes and enhanced Java SE 8 support, so you can use it outside of container and on the desktop. So this is, for example, one of the things with synchronizing with Java SE 8, adding in support for using streams for parsing stuff, and a fluent syntax with it. JSON pointer is similar to XPath in the XML world. So this is basically a way of being able to specify paths within a JSON file. So that was also coming in JSON-P 1.1. So as you can see, things that you kind of have to home grow today and try to build or use a non-standard implementation. So this shows how it may incorporate it. JSON-Patch is very similar to the concept of HTTP patch. It allows for issuing commands to modify JSON documents in a generic fashion. So here we're basically showing how we can go through and update a JSON document. We want to change the age to 30, remove the phone number, add the first name, copy the the last name over to the last name field elsewhere, and then build it back up. So this is what This is what's hopefully coming along with JSON-Patch. So finally getting support in there for right there, because right now the API is fairly basic. You have to write a lot of code to do very simple things. Okay. The Java EE Management API was supposed to supersede the current EJB-based management APIs and define a newer REST-based API for working with managed object. The reality is that this API hasn't gotten off the ground yet, although it was fairly popular on the survey. So if you want this API to move forward and to have a standard Java EE management API, you have to get involved in helping this push forward. Join the expert group, pester them, try to get them moving along. Find the more people that pester and move things forward, will actually get this happening. So as I mentioned, so it was supposed to be a REST-based interface that supersedes JJB, monitoring deployment, standardizing monitoring of deployment, server-side event support, and also WebSocket support was also under consideration as a part of the management API. So as I mentioned, all of this is kind of ground to a halt, and it doesn't look like at this stage that would make it actually into Java at EE 8 unless people speak up and we get this moving once again. Okay. So new specifications. So that's the stuff that was there. So in terms of new stuff coming along in Java EE 8, one of the big ones is MVC. So this is a new action-based framework which has been proposed for inclusion. When they did the survey, there was not one one existing framework that everybody said, we should look to that and standardize off of that. So although there was, Spring MVC and struts out there, the community really didn't seem to, go with one or the other, or didn't seem to have a strong preference with that. And I know if you mention struts, a lot of people, it's the really old way of doing things. So this framework is based upon the model view controller architecture. This one was very active in the beginning, but has since slowed down significantly since late 2015, as have the other ones. However, you can download the reference implementation Ozark and play with it. There were a lot of good presentations up there on how to use it, so you can go check out that. There was a Devox UK presentation, which was very good, that went over there, but it's not out yet. So it's an action-based web framework for Java EE. It follows, in the same patterns as Spring MVC or Apache struts. So it's basically standardizing it. Although we do have JSF, and at one JSF on the platform, that doesn't, solve everything for everybody. And it's becoming more important given how people are writing applications where you're doing your front end, in Angular and making RESTful calls to the back end, right? So there's a heavy emphasis on the HTML5 stuff right now on the front end. So that's more to fit into this type of world. So it does not replace JSF, it complements it, right? Because it used to be you were either doing a struts application or a Spring MVC application or a JSF application or a JSP application. So the model, it ties all of our Java EE technologies together. So it pulls in CDI, bean validation, JPA, ties them all together. You can use facelets or JSP. JSPs is the view technology. It has a controller layered on top of JAX-RS. So this actually pulls in and uses, heavily depends upon JAX-RS underneath the hood. Or not actually underneath the hood, you see it in the code samples. So this is an example of a controller here. So as you can see we have our JAX-RS annotations for the URLs, that's /customers. We define what the view is. We then using injection to inject models. It's models, not model, because model comes from the JSF side of the stereotype from the JSF side of the world. Then we have our endpoint here, which is to retrieve the list of items. So this is an example controller. So both the get and the path are from JAX-RS, and also the view that's being rendered. The views for a MVC application can be written under any number of view technologies. So this is an example using facelets here. So this is looks fairly standard. So we have our form, our action, the URL for editing. So this is basic, fairly simple example of using it. Okay. JSON-B. Java EE 7 includes a low-level JSON parser, which is akin to JAX-P in the XML world. So JSR 367 was trying to finally get JSON binding. So how do you take JSON that comes in and turn it into Java objects? So this is a very important piece of the puzzle, especially in the cloud. It's been moving forward fairly well. And you can download the specification and check out you can download the API and take it out for a spin. So this is one of the things that, right now if you're using like the Pyro app container, it's kind of doing things for you underneath the hood in a non-standard way with Moxie, right? So you can send, JSON to a server and to a service written on Glassfish, and it will turn it into a Java object for you. That's actually not standardized across all app containers. So with this, that's actually standardizing it, and with its integration with JAX-RS, it means that you could reliably call, you could reliably implement a service for different containers that would be able to accept JSON and turn it into Java objects. So this should be this API is highly transparent, so it'll standardize, as I mentioned, the means of converting JSON to Java objects and vice versa. It has a default mapping algorithm for converting Java classes. Draws from the best of breed of ideas on existing JSON binding solutions. So remember what I said is that Java EE is a standard, so it looks at what's been done out there already. So we already have tools out there that are trying to accomplish this, right? You have JSON, which does JavaScript, JSON to Java object binding. So basically it's trying to standardize this and take what's been learned from Moxie, Jackson, JSON, Jensen, as well as the other ones out there. And integrates with it. So this is an example right here where we have our annotated class, right? And we want to take and convert it over into JSON. So two different. So it'll basically, you take a JPA entity that's instantiated using a new operator, manipulated, and then you want to be able to turn it into JSON on the output using JSON-B. So this is the idea. We'll be able to take and convert our Java objects easily, be able to mark them up with annotations and convert them to JSON. Custom mapping is also possible because the default one doesn't always work or doesn't always solve all the potential problems out there. So there will be custom mapping capabilities added into it as well. Okay. Java EE security. So this is one of the things. Security is, of course, becoming more important. Now if you're writing applications, you have to worry about things like OAuth, and so this was a highly desirable one in the Java EE survey. So JSR 365 claims to target this. So it's still an early draft review. Along slowly. So the goal is to radically streamline Java EE application security, improving portability, especially in the cloud. So this is becoming more important as people write cloud applications. So the API would promote the use of standard modern concepts instead of customized solutions, and also include the use of expression language support as well as CDI. So security is one of those things that everybody seems to do a little bit differently in terms of how they implement it. So this will hopefully finally standardize it on the platform. So we'll have simple security providers, easy pluggability and mapping, enable existing security annotations for all beans. So it'll make it much easier to work with security going forward. And so some of the proposed ideas and examples are out here on GitHub, so you can check those out today. And there's also a good Java 1 presentation last year on security. So this is an example of a proposed security provider. So as you can see right here, we're injecting our security service. On authentication, we're constructing the principles. And then on authorization. So if you've ever messed with the Java EE security, often you'll get the principal back, but then you want to know, okay, what user? I want to have a bunch of information hanging off of that the user's address or some additional information. So this will finally standardize that type of stuff. So as I mentioned, many applications nowadays are using homegrown solutions, which may or may not be secure, or may not have security holes in them. So by standardizing this can improve it across, improve security on the Java EE platform and make it much easier to use. Next one was JCache. So it's temporary caching API. This one sadly missed the Java EE 7. It hadn't been finalized in time. So the goal with Java EE 8 is to finally include JCache 1.1 in the platform. So the goal of this is to make it a lot easier to add caching to the platform and to use caching on the platform. In fact, caching, in my opinion, is one of the things that should be standardized. Should be standard in every application. You should be using caching to share data between server instances. So it would define. So if JCache became a standard, it would define a common set of caching concepts and facilities for using it in Java EE applications. This would minimize the learning curve with using it, increase portability of the applications, and support in-process and distributed cache implementations with your applications. So other ones that I haven't discussed yet, and which really aren't on the roadmap, are changes to JPA, WebSockets, concurrency utilities, and batching. These really haven't been discussed at all in the context of Java EE 8. So the stuff that I've said that has slowed down or basically stopped development on, but then these aren't currently, they're not currently in the bucket of, there's not much going on with these different standards for Java EE 8. So there's no, for WebSocket support, I think one of the limitations that I run into with that is just how to handle security with it, right? So there's no planned, at last check, there's no planned revisions, planned changes for these in Java EE 8, which is kind of bad. So, and there's no plans for updating some of these with regards to like changes in Java in Java 8. So that's a concern, and that's why we need the community involved to try to push these along and make them take notice. So as you can see from the presentation, I mean, there's a lot of really cool things that look like they were going to make it into Java EE 8, but things have slowed down substantially with a lot of the traffic being drying up. So previously, Oracle had been looking to be a terrific steward of Java EE. In fact, I've been surprised since Oracle bought Java EE, since they bought Sun and took over ownership of Java. I've actually been very impressed with how they were improving the platform. We'd finally gotten back to regular releases of Java itself. They were going back to the 2-year tick, where every 2 years we get a new version of Java, and so things looked like they were moving along great. And then suddenly, after Java 1 last year, everything kind of stopped. As Oracle focused on everything, which focused on all of the cloud stuff. So you can start working with Java EE 8 today, but there's no app containers that are out there that are Java EE compliant. Glassfish 4.1, there's builds of it out there for Java EE 8, but I don't believe there's really been any commits on it. In fact, Oracle has kind of dropped maintenance of Glassfish. There's not been really any commits of Glassfish. In fact, if you're using Glassfish 4.0, there's some pretty serious defects in it, which will prohibit its use in like a production environment. So you have to, right now there's a company over in the UK that's taken over. It's called Pyrafish, which is, they're releasing regular updates to Java EE, to Pyra, and I believe they also have a Java EE 8 distribution. So it's really important to take action and get involved. Okay, so this is the current timeline for it, and so right now, I think 2017 was the original, or the current target release. I don't think that they'll make that, given the lack of progress that's out there. I don't see how they can, because most of the stuff isn't ready for prime time yet. I'm just looking at the lack of commit and the lack of commits on the Java on Glassfish EE 8 support. So it's at least a year or two away. So a group of us, basically led by Reza Rahman, started this Java EE Guardians earlier in the year. And there's actually, if you go to this website here, I'm the one that adds your name to the list. So if you email it, that we have a Google Groups which discusses things, and there's basically a petition that you can sign. We have a change.org .petition, which is being sent to Oracle. And this actually garnered enough interest in Oracle that they finally had to actually respond. So that's where you saw like a month or two ago, it was because of the Java EE Guardians that they finally had to say, no, Java EE is not dead, we're not trying to kill it. So things have been moving along actually positively. It looks like things are, they said they're going to restart it, although it was kind of from some of the press releases that went out there, it's not clear as to whether they're going to come out with a bunch of new JSRs next week and surprise everybody with cloud support or something, because something's going on in the smoky rooms. But what we don't know. But they've at least come out and saying they're still committed to Java EE, which is a good thing because we don't want this to die. We don't want this to become a proprietary solution. We don't want all of our app vendors to now, split, right? Where you write an application for JBoss and it's permutating into something completely different that you couldn't take that application over to WebLogic, right? So we've had this wonderful ecosystem where things have competed, where we've had a standard implementation where people have competed on adding additional features on top of that. So you could start out on Tomcat and then move to WebLogic as your application or company grew. So that's been one of the nice things about this platform, right? You didn't have to, you had that opportunity. So so please sign the petition. There's also a survey that's going on. I think it actually just closed. We were looking at some of the new features that we wanted in there, but sign the change.org petition, sign the petition on there to get involved, because Oracle actually did take notice of that when we started raising the red flag, because there was no press announcement when all of the stuff just kind of stopped last year. Oracle didn't come out and say, we're focusing on cloud stuff because we're getting hammered by Wall Street for this. They just kind of silently moved all the resources off. You'd have to look at the commit logs to realize that stuff had stopped. So it was, for those of us, it was like, what happened? And there's also, you can get involved, there's also Adopt-A-JSR. I don't know if Java Groupin is involved with that at all, but that's pretty important for getting involved, that they have this, the ability to Adopt-A-JSR, get involved with the JCP. They've actually simplified many of the JCP, the ability to participate in the JCP in terms of being able to join it, the legal agreements that you have to sign. So there's some good presentations up on SlideShare from Heather on how to get involved with the JCP. So please do that, and that's it for Java EE8. So if there's any questions?
Yeah, I was wondering if you could elaborate more on what happened, because you've mentioned that quite a number of times, that commits stopped, resources have been moved, and all of that. Could you elaborate more on?
I think, well, I don't work for Oracle, and nobody from Oracle will comment on exactly what happened. So so yeah, I mean, the best one that I had, the best example was Nigel last year on the JMS discussion list, where he said, I can't, the meeting for this week and all future meetings are canceled, right? And so, and that was, I mean, he was, the other specs, things just kind of stopped, right? And so it appears that Oracle, I'm guessing, had some other projects internally, because they're trying to get everything onto the cloud, right? So if you read the papers, they're getting hammered every quarter as to how they're doing on the cloud against Amazon and Google, right? So it sounds like they had shifted resources, everything was moving over to cloud, so unless you were working on cloud, you were in trouble. So that's what appears to have happened, is the pressure from, Microsoft Azure and Google and Amazon, Oracle was reallocating resources. So I don't know, I can't say what's going on internally in Oracle. It kind of happened over time that they just reassigned and moved everybody over, I'm guessing. And so they've now come out and said that they're going to start it back up, that they're heavily committed. They issued a bunch of PR releases, which Oracle usually doesn't respond to anything, right? They had that article last year that said that they didn't come back and not sorry, that it was an old language or something, but they didn't refute that one. But since the Java EE Guardian started up with the petition and everything, then they suddenly said, no, we're committed, but we still haven't seen progress yet on the discussion list, right? I don't remember seeing any recent messages on the JMS discussion list. And so this is really, we really don't want this to die in the vine. You don't want to have to go back to the mid 90s and where we were back then, where you had, PHP, you didn't have this nice ecosystem. If you look at how broad this ecosystem is, how many people, depend upon it, right? JSPs, JSF. I mean, if all of this stuff kind of died over the next, couple of years, that would be kind of sad, right? Because we've had this stability for so many years. We've had JPA and everything like that. Transaction just look at the Java Transaction Manager, all the stuff that we've learned from over the years in the standards-based approach. To lose this would be a very sad thing. So it appears that it's not, Oracle is taking the community seriously in that. So I don't know what happened internally.
Okay, I think I'm going to break off here. But thank you very much, Ryan. Very interesting. Java Enterprise Edition is alive, but needs support. Thank you.